So let's talk about equations. So far we talked about the functions that have polynomial over polynomial, we had the restrictions, so on and so forth. So what would happen if we do have equation? It means that my fraction is going to equal to a number on another fraction. How I can deal with that? Let's see that what are the very simple steps that we can do in order to solve that function. The very first one is that find the restriction. Again, this part is so important because you are going to forget that if you don't do it at the beginning. So what does that mean? It means that after you do the factoring, you do everything, you have to find the no-go condition or no-go situation that make your fraction as 1 over 0, 2 over 0, or whatever. After that, you have to clear the fractions. The very first thing that I'm telling my students is that try to get rid of fractions. It doesn't matter, you have numbers, you have functions, try to get rid of fractions because they're going to deal some issues with it. What does it mean? It means that you have to multiply both sides by the LCD of both fractions from both sides. For example, I do have x2 subtracted by 4 divided by x minus 2. I do have x plus 2 divided by x minus 2. The very simple thing I can do is just multiply both sides by x minus 2. I know that this x minus 2 can cancel out this x minus 2, but right now this x minus 2, this one is going to cancel out this one. The final some kind of equation would be x2 minus 4 is equals to x plus 2, which is the quadratic equation. That after reaching to that value, we have to solve the issue or some kind of solve the problem, find x, and at the end I have to find the integrity check. Why we are doing that? Because the final step, the fourth step, and the first step are so tight to each other. At some point, you are finding your restrictions, and after doing everything, all of this step, you will find some answers. You still have to check your final answer with your restrictions, because it happens, actually I'm going to show you in the next example, it happens that your final answer is going to be as the same as first answer, and you will cause some problems because at the end of the day it would lead you to 0 over 0, still undefined. So we don't want something like that happens. That's why we have to make sure that we find the restrictions and then we check the final answer with it to make sure they are not going to be the same. So right now let's look at it. I do have x to the power 2 subtracted by 4 divided by x minus 2 is equals to x plus 2. So we know we would like to get rid of fractions, so multiply both sides by x minus 2. This is something that is a fact. So it means that this guy is going to cancel out this guy, but x plus 2 is going to be times x minus 2. So if you do that, it would be x2 now subtracted by 4. You should just do it by yourself. You can completely understand it. It doesn't have that much of an issue. So at this point, first of all, I know about my restriction, which x is equals to 2 is my restriction. So this is something, keep it that way. That was for the first step, keep it that way, that x cannot be 2 itself. So after you solve this equation, you would reach to something like this. On a time that you reach to something like this one that at the end leads you to 0 is equals to 0, it means that your some kind of function or your some kind of equation can be true for any number. Actually, it means that the first side and the second side actually were the same, but in different form. Because as you can see over here, if I simplify the first one, x2 subtracted by 4, we know it from the perfect squares, it was x minus 2 times x plus 2. And if you divide it by x minus 2, these two things are going to cancel each other, so it equals x plus 2. You didn't even have to do anything. At the beginning of the point, you knew that is a fact. Everything out of this slide from the first side is going to be the same as the second side. So it means that I can have all of the numbers. But can I? Because from the very beginning part, I know x cannot be 2. So my final answer is going to be everything rather than the 2 itself. So I have to be very careful about that restriction rule. So what about inequalities? We talked about inequalities in our functions on a time that you have only maybe 1x, or maybe at the some kind of worst case scenario you have x to the power 2 on one side. But what would happen if you do have a fraction that each of them are going to be polynomial? What we should do on that time? The very first step, again, is to find the restriction. But not only we can find the restriction and use it, we also can find the number that is going to make the numerator as 0. Why? Because you know, at that time that when numerator is 0 and denominator could be 0, or any kind of something would change. So we can first of all find the boundaries, and after that talk about what would happen between boundaries and before boundary. So let's look at it. From the first part, the very first step is that I have to find two zeros. At the beginning of the point, a number that makes my numerator as 0, which at the end of the day is going to make my expression 0. After that, we have to find the 0 that happens in denominator, which is going to make my system undefined. Because at this time, I know this some kind of sign would change. So find all the critical ones, and these values are going to divide the lines into the test intervals and pick up the test that actually, for instance, let's see an example. I do have x minus 1 divided by x plus 2, and I would like to find the parts or find the range of numbers for x that if I put them there are going to make this fraction as bigger than 0. So again, x is equals to 1 is my first critical point. X is equals to negative 2 is my second critical point. I'm going to have them over here. And let's consider the condition that what would happen if I do have my number bigger than 1. If my number is bigger than 1, obviously this part is going to be positive, and this part was the positive, so this is going to be positive. So this point is a check mark for me, because positive divided by positive is positive. What would happen if I do have my number smaller than negative 2? And any number smaller than negative 2 obviously is going to make this guy as negative, and it's also going to make this guy negative. Again, negative divided by negative is this thing that I like, another check for me. But what would happen between? At this point, if I put any number between negative 2 and 1, is either going to lead me to a fact that I do have positive or divided by positive. So at the end of the day, I'm going to have this one, which is going to be negative itself, and the final solution would be all of the numbers smaller than negative 2 or bigger than 1 itself. So let's talk about the behavior or anatomy of a rational graph, because if you guys remember, for the previous part we talked about the normal functions, that how they're going to react or how we're going to draw them based on forbidden points, based on some kind of number of degree, and based on the leading some kind of coefficient, and etc. So right now we are trying to see that what would happen if I do have the polynomial at the top and a polynomial at the bottom. First of all, about the behavior, after that about some kind of restriction points that we know about their unbreakable law, and so on and so forth. So let's dig into it, see what would happen. The very first thing that we have to know is about the hidden scaffolding vs missing pieces. So what does that mean? If you guys remember, when we were talking about fraction, the very first thing we saw was about the restriction part related to the denominator. It means that wherever denominator is going to be 0, it's going to be the red flag. So we have to go there. And also, we had another part that was related to what? To the numerator there. It means that that guy is going to be 0. But we only use the numerator part in order to look at the visualization. It's going to help us in inequalities. But it means it's not going to be that red flag for us. So we are going to put our focus over the some kind of denominator itself and the restriction point. Let's see what is happening. The very first thing is that about the vertical asymptote. What does that mean? It means that I do have a condition where a factor of x minus c remains in the denominator after all of the simplification. So the vertical asymptote is going to be x is equals to c. What does that mean? It means that, for instance, I do have 1 divided by x minus 2. So x equals to 2 is going to be my forbidden point. It means that if I do have a variable there, for sure my f of x or final answer is going to be undefined. So I have to get rid of that. How I'm going to show it in the graph. If you look at the 1 over x graph is most like this. So this of the parental functions that we had in the previous slide is going to be like this. When you do have 1 divided by x minus 2, probably I have to move 2 to the right. So right now, this line, which I know it as x is equals to 2, is completely out of the topic. So I cannot have it. Why I cannot have it? Because x minus 2 or x equals to 2 is going to lead me 1 over 0. So this one, the domain is can be any number rather than x is equals to 2. So I do have it as the boundary line. Another thing that I have is about the whole itself. What does that mean? At some point at the end of the day, when you have a line like this or have the simplified form like this, for the fact that of x is just a linear function. It's just not going to be like the previous one. It's just a linear function. So it would be y equals to x. Yet I have to make sure that I'm not going to have x is equals to 1 there. Why? Because x is equals to 1 was my restriction, and this is a hole. So right now this is a hole, but this guy is going to be boundary line. This is the difference between them. So what would happen if the condition would be a little bit more complicated? It means that I'm not sure what is happening at the end because I cannot simplify it all the time. So but I can get some help from two things. The first one is the degree, and the second one would be about the leading coefficients. What was the degree? We know it from the previous descriptions and from the previous subject. Degree means that if I do have the polynomial, the highest power of my factor could be x, could be anything. The highest power is going to be considered as my degree. If I do have x to the power 4, the 4 is a degree. If I do have x to the power 2 is a degree, right? So I consider that one as a degree of the numerator, and I'm going to consider another degree for the denominator. So I'm going to compare those. Based on the comparison, 3 common conditions could happen that we are going to talk about it. The very first one, if I consider that n is going to be my numerator degree and m is going to be denominator degree, is that my degree of m, for example, let me show it as x to the power of n and x to the power n. I'm talking about this division. So imagine that I do have this condition. At this point, the bottom is going to be heavier. It means that if I increase my x, for sure I'm going to reach to a point that I will lead to this one. 1x to the power of n is, by the way, this guy, if you just some kind of solve this one, it would be something like, for example, x to the power 1, x to the power 2, and etc. It means that at the end of the day, by increasing the number of x or increase the value in x, my whole fraction is going to decrease to reach to a number that is going to be somehow 0 itself. Not only in the positive section, but also in negative section. So it means that if I increase the x, is going to be 0. If I again decrease the x, is going to be 0 again. Still, I have to make sure that x is equals to 0 is my forbidden part. Why? Because at the end of the day, I do have 1x in denominator itself. What about the second number 2? At this point, my n and m are going to be the same. So right now, I don't have any choose, or I don't have any some kind of options to look at the leading coefficients. What was the leading coefficients? You guys remember ax to the power 2, a is the leading coefficient. Bx to the power 4, b is leading coefficient. So leading coefficient is the one number is going to be beside your x or whatever variable that you have, while that x or variable has the highest amount of power. This is going to be considered as our degrees. That guy is a leading coefficients. So I do have this one. It means that a divided by b, for instance, if I do have it that ax to the power 4 and bx to the power 4, a divided by b is going to help me. Why? Because at the end of the day, if I increase the x to the maximum positive or to maximum negative, still this a divided by b is going to be the thing that I elect. So this guy is going to be y-axis, can be considered as my some kind of the leading factor that I would know it. It means that my system would like to reach out to this line, but it cannot. Because at the end of the day, something could happen and we cannot have the exact same number like this. So this could be my some kind of leading factor. And at the same time, I know for a fact that x is equals 0 is out of some kind of limit. So this is a boundary line and this is the leading line. So what would happen if I do have a case like this? That top is going to be heavier only by 1 number or 1 degree. At this point, we say that the slant or oblique symptom is happening. It means that some kind of the leading function or some kind of leading number that we had like this is not going to be simple anymore. This leading number is going to be something linear. By the way, guys, this last part is going to be more advanced because at the end of the day, you have to find a linear function and see that how it's going to have its angle by some kind of respect to x-axis, and it's going to be more advanced. We're not going to touch it, but just let's assume this condition that if you do have a part or if you do have a situation that the degree of your numerator is going to be only 1 and only 1 bigger than denominator, something would happen like this. It means that my line or the leading part, leading one, is not going to be a number, it's going to be a linear some kind of equation. So far we had 3 conditions where I had my power or some kind of my denominator or bottom is going to be a little bit heavier. When I do have my condition that both of them, they do have the same degrees, and the point that my numerator is going to be a little bit bigger only with 1 degree itself. Maybe some of you would ask, all of those questions are going to be x to the power 4 divided by x to the power, for instance. So what would happen if I do have other kind of terms? So when we're talking about the highest, some kind of the biggest number that it has the highest power itself, we are assuming that at the end of the day, we are dealing with big numbers. When you're dealing with big numbers, those other terms like x to the power 1, number 2, 3, 4 are not going to be considered because they don't have that much of effect of our system. Imagine that you have the x to the power 4 in one hand and you have x in another hand. Obviously, at the end of the day, x to the power 4 is going to be way bigger than that x. So we somehow consider they are ignored. That's why we are only going to work with some kind of the highest power and the leading coefficient, because these two things actually matter. So after that, let's try to work in the real world problem, how we can some kind of use that in the real world and day-to-day life. Imagine I do have a scenario, and in this scenario I do have a company and it has fixed cost of $1,000. This means that at the beginning of the day I have to consider $1,000. It doesn't relate it to any formula. It's just a constant number, which we know it most of the time as C. And it costs $5 to produce each unit. We want to model the average cost per unit. What does that mean? It means that I do have a fraction, and this fraction is my cost, and also it's going to be the total cost, by the way, divided by the cost for each unit cost. So I'm going to model this one. What does that mean? It means that first of all, I have to find a function that is related to total cost. It has a constant value, $1,000, plus 5x is going to be $5 per each unit, 5x. So this is going to be my numerator. So after that, I insert some kind of cost for each unit, which based on the question was x. So at the end of the day, I do have the average cost as this. And the question is, what would happen if I some kind of specific value? What is going to be some kind of my average cost at the end of the day? So you would say that the total cost is like this, and the average cost is going to be this function. So I'm going to analyze this one, and I'm going to see that what is going to happen to my model. By using this one, I can find the average cost for any number of models that I'm producing. For instance, the question asks, what is the average cost, for instance, 100 units? The only thing that you have to do is just put x as 100 and put it over here. It means that the average cost would be 15. And what would happen at x getting very large? It means that I do have a condition. It's just like the second condition, that's n and m are going to be the same. What does that mean? The degree on the top is 1, the degree on the bottom is 1. So it means that I have to only look at the leading functions. This guy is going to get rid of that. So I do have 5 as a leading coefficient, and I do have 1 as a leading coefficient. So I can say at the end of the day, 5 would be an average cost. What we understand, as the production increases, the fixed costs are spread over more units. It means that this 1,000 is disappear by the time, and the average cost per unit is going to approach the fact that $5 each. So this is going to be the master blueprint that I put you over here. You can just look at it. I'm going to show up my video over here. You guys just look at this one. So the very first of the thing we learned was about manipulation. We understood that how we can add and subtract some kind of the fractions that we have was about using the LCD. After that, we learned how we can solve them, equations, and also inequalities by finding critical points, boundaries, and by knowing the fact that we have to also be careful about the restriction points. Also, we talked about the domain part. It means that what are the factors or what are the values that are going to cause me some problems? Are going to be the holes? Are going to be some kind of vertical asymptotes? How are they going to be? We also talked about the degree of the comparison between n and m. What would happen? 3 conditions. The first condition, second, and the third condition. And at the end, about the interception. What would happen if I would like to find x-intercept, which means that my px is equals to 0, and what would happen if I would like my y-intercept, which means that f of some kind of 0 is going to be a specific number. So far we talked about the condition that we do have the combination of polynomial, one on the top, another one on the bottom, and following all of these blueprints, right now we do have a very good knowledge of what is happening beside of that. So try to rewatch the video again, solve the questions, pause the videos, think about it, and if you have any problem, comment me down below. I try to my best to help you as much as possible. Thank you very much for being here with me. Don't forget to share and comment. It's going to be so helpful for me. Have yourself a great night, what a day, whatever. See you around.